Welcome students to another lecture on engineering graphics. Today we will take fourth problem on orthographic projections. So let us start the lecture. So we are given one object and we are asked to draw front and top view in first angle of projection. So we know that if we have to draw projections of any object in first angle, that means we have to assume that object is in the first quadrant. And before starting any problem of orthographic projections, first of all we have to locate the front of the object. So in this picture, one arrowhead is given to us and that arrowhead is pointing towards the front side of the object. It means we have to assume that observer is standing this side. And this is the front side of the object. And if you are solving this problem in the first angular projection and observer is standing here and this is the front side, it means front view of the object will be obtained on vertical plane that will lie behind the object, and top view of the object will obtain on horizontal plane that will lie below the object, because we are considering that object is in the first quadrant. And let us see the dimensions also. If observer is standing this side and this is the front side of the object, then dimensions moving from left to right of the observer are length dimensions. Dimensions moving towards VP or away from observer are width dimensions, and the dimensions which are moving in upward direction are called as height dimensions. Now let us discuss its front view first. Now we know whenever we have to draw front view of any particular object, we have to see two kinds of faces. We have to see faces parallel to VP and faces inclined to VP. Because when observer will look at object from front, only two kinds of faces will be visible. Those will be parallel and inclined to VP. So over here, in this object, we have included curved faces as well. In the first problem on orthographic projection, we talked about an object having parallel and perpendicular faces. In the second problem, we talked about object having parallel and inclined faces. In the third problem, we added hidden faces also. So in this fourth problem, we are adding curved surfaces also, and we will see how to plot their projections. So let us start with the front view of this object. So in order to construct its front view, let us see how many total number of faces are there. So you can see this is first face, this is second, third, fourth, fifth. Five faces are there, and hole is also present in this particular face. So when we look at this object from front side, we will see only two faces, because in this object there are only two faces parallel to VP and there are no faces inclined to VP. So there are only two faces parallel to VP. The first face is over here and second face is this one. So out of these two faces, let us pick that face which is close to HP. So let us start with this face. So let us pick its lower left corner. So from this point, we will start the drawing of this face. So let us mark this point on the drawing, and from that point draw this length. How much is this length? It will be equal to 40 minus 24 divided by 2. So that will be equal to 8 millimeters. So we will draw a length of 8 millimeters on paper. So this is representing this length of face 1. Now we reached up to this point. Now from that point we will draw its height, and this height is given to us as 6 millimeters. So from this point we will draw a vertical line of 6 millimeters. Now from this point we have to sketch a length of 24 millimeters. So we have to draw a continuous thick line again from that end, and that will be of 24 millimeters. So we have reached to this point, and from that point you have to move down. We have to draw a height of 6 millimeters again. So from this point draw a height of 6 millimeters. Then we have reached to this point, and now we have to construct this length of face 1, and it is again equal to 8 millimeters. Now from this point we have to draw its height of 14 millimeters. So from this point draw a vertical line of 14 millimeters. Now from this point move towards left and draw a length of 40 millimeters. So from this point we will draw a length of 40 millimeters. Then we will join these 2 points with a vertical line that will be of 14 millimeters. So you can see we are ready with the drawing of the first face. Now we will draw the drawing of second parallel face. So in order to draw the drawing of this face, what we need to do, we have to pick points, of course. So in this face, you can see there are 2 points, and out of these 2 points, let us pick any one point and locate that point in the first face drawn by us. So let us pick this point, and this point is exactly behind this point. It means this point on the drawing is representing this point. It means from that point we can start the drawing of this face. Okay, now let us start the drawing of second face from this point. So from this point we have to draw a straight length of 30 millimeters. So you can see this face consists of two straight heights on both sides, and after that we have a curve, and radius of that curve is given as 20 millimeters. It means from this point we have to sketch a vertical line of 30 millimeters. Now from the other point of this face, that is from this point, we will sketch again a height of 30 millimeters. So we have drawn these two straight edges of this face. Now we have to construct this curve. So how to construct this curve? First of all, we will draw a center line in order to locate the center of that curve. So let us draw a center line, and after that we will locate the mid of this distance. We know that this length of the face is equal to 40 millimeters. So mid of this 40 millimeter length will be at 20. So at 20 millimeters we will draw another center line, a small center line of around 15 to 20 millimeters, and we will get a center. The intersection of these two center lines will be the center of this particular curve. Now the radius of that curve is 20 millimeters. So we will put our compass at this center, and we will open compass to this radius, that is 20 millimeters, and we will construct a curve with the help of compass. So we are ready with the drawing of phase 2. But in the phase 2 we have a hollow portion, means we have a hole also which is of diameter 16 mm. Now one thing to understand over here, if we are given any hole and if its depth is not mentioned, then we have to assume that this hole is throughout the width of that face. Now you can see the dimension for this hole is given as phi 16. Phi represents dia, so dia is 16, but its depth is not mentioned. It means we have to assume that this hole is throughout this width. So let us draw this hole now in the second phase. And how to draw this hole? We simply have to construct a circle of diameter 16. So we will use compass. We will put compass at the center, and we'll open the compass equal to the radius, that is 8 millimeters, and we will draw a continuous thick circle. Now you can see we are ready with the front view of this particular object, because in this object there were only two parallel faces and both were visible. There was no inclined face and there was no hidden face. So we are ready with the front view of this object. It was quite simple. Now we know after front view we have to draw a reference line, and we have to draw a reference line in this case below the front view by leaving 10 millimeters minimum gap. Why we are drawing it below the front view? Because we are constructing in first angle of projection, and in first angle of projection front view always lie above reference line. Now from all the points of the front view we will draw projectors in downward direction. These are continuous thin lines parallel to each other and at 90 degrees to the reference line. So how many projectors we will get? 1, 2, from the diametric ends also. We have drawn from center line as well, which will help us to locate the center in the top view, and we have drawn from these 2 points as well. So total we have drawn 7 projectors. Now after this we will construct its top view, and we know in order to construct its top view we have to maintain this direction, but now we have to look from top. So we have to maintain this direction and we'll look from top. Now from top we will see only those faces which are either parallel to HP and inclined to HP. So let us see how many faces we can see. So when you will look at this object from top, we will see this curved face. Then we will see this horizontal face. Then you can see there are three hidden faces. This face, and this one. These three faces are hidden behind this face. And apart from these three faces, there is one hole also, which is not visible from top, but we have to represent that hole as hidden. So it means we have concluded that there are two visible faces. One is the curved face, second is this horizontal face, that is parallel to VP. After that, we have to show three hidden faces, and these three faces are parallel to HP, but these are hidden below this face. And we have to represent this hole also as hidden below this surface. Now let us first start with curved surface. If you can recall the very first lecture on orthographic projections, in that lecture we learned that if we look at any curved surface, we will see a flat face only. So when you will look at this curved surface from top, its projection will be a rectangle only, and the length of that rectangle will be equal to the length of this face, that is 40 millimeters, and width of that rectangle will be equal to the width of this curved face, that is 14 millimeters. Okay, now let us locate this particular face. So what we will do, we can start from this point. Means when we look from top, we can see this limiting edge or limiting element of this curved surface. So what is limiting element? The last visible part of the curve. So from this point where this straight line ends, we can sketch a line here. So that will be the last visible part of this curve. So we'll call it as limiting element. So from this point, we will start the rectangle as a projection for this curved surface. So we have to locate this point in the front view, and we know this point is behind this point, and that point in the front view is over here. So from this projector we have to start our drawing. So from this projector we will draw a rectangle whose length will be of 40 millimeters. So from this projector let us start a continuous thick line. So this edge is the edge of this curved surface, this edge. Though it is curved, but from top it will be like a straight line only. After that, we will complete its projection. That will be a rectangle only. So from here, we will draw a width of 14 millimeters. Then again, we will draw this edge, though it is curved edge, but from top it will look like a line. And that line will have a length of 40 millimeters. So from here again, sketch a continuous thick line of 40 millimeters and complete its view. So you can see when we look at this curved surface from top, its projection will be a rectangle only. So after that we have to plot the second visible face, that is this parallel face. So in order to plot this face, we have to first see how many points are there, and we have to pick one point and we have to locate that point with respect to the previous face drawn by us. So let us pick this point of the second face. Now you can see this point is exactly below this point. That point is over here. So from this point we will sketch the width of the second face. So how much is the width of second face? It will be equal to 44 minus 14. So this will be 30. It means from this point we will draw a width of 30 millimeters. Then we will draw this length of 40 millimeters. Then we will complete this face by drawing this width of 30 again. Now we are ready with the visible faces. Now we have to plot these three hidden faces. Now these three hidden faces are hidden below this particular face because we are looking from top. Or we can say this face is divided into three parts. That's it. If we will represent for this middle face, other two faces will automatically be represented. So or otherwise if we represent these two faces, then third face will automatically be represented. So in order to represent this face, what we can do, we have to show this edge and this edge of the face, which is hidden below this face. And one more important point we have to understand, that Over here, this recess is given to us and its depth is not mentioned. So we have to assume that this recess is throughout its width. It's throughout its width. Now let us locate these 2 points in the top view. Now these 2 points in the front view are here. So from these 2 points we have these two projectors, first projector and second projector. And we have to draw this recess throughout its width. So this is width. So from this projector and from that projector, you will draw dashed medium lines. You can see we have represented this edge and this edge by drawing two dashed medium lines. Why? Because these two edges are hidden below this face. Means these two edges are hidden below this face when we look from top. So we have drawn two dashed medium lines for that. Now you can see we have represented this face. So this face is represented. So when you will represent middle face, automatically these two faces are also represented. This edge of this face is below this edge. So it is hidden behind continuous thick edge. So over here we cannot draw dash medium line. Why? Because if one edge is hidden below other edge, then we will give preference to the visible edge. So we will show visible edge as continuous thick lines on both sides. So we have represented these three hidden faces also. Now we have to represent this hole. And in the very first lecture of orthographic projections, we have learned that if we have to represent a hidden hole, then we have to draw the limiting element of that hole by dash medium lines. So you can see from this hole, from this circle, we have drawn two projectors from the diametric ends. So these diametric ends are the limiting elements. So this hole is in this particular width only, that is 14 mm. So that 14 mm is here only. So it means we will convert this projector and this projector for this width of 14 as dashed medium lines. So you can see this dash medium line is for this diametric end and this dash medium line is for this diametric end. And we have represented this hole only in this width. Fine, because hole is in 14 mm width only. So after that we will draw its center line also. Now you can see we are ready with the top view as well. Now it's time to place dimensions. So let us remove the projectors. After that we will place height dimension. Then we will place complete length, complete width of the object. After that we will place remaining height dimensions. So we will place this 14 mm height and this 30 mm height. So we will show that this height is of 14 mm. Then we will show that this center line is at 30 mm from this particular surface. Then we will show this height of 6 millimeters. At this point you can see how we are representing. We are leaving 1 millimeter gap and we are drawing a continuous thin line, that is extension line. And note this dimension. We have insufficient space to accommodate both the arrowheads. So what we did, for such cases we have to draw arrowheads outside the extension lines. So we will extend the dimension line on both sides of the two extension lines and we will place arrowheads outside, and arrowheads will point towards the extension lines, and above the dimension line we will place the dimension. So this method you can adopt if you have small dimension and you cannot accommodate both the arrowheads inside. After that we will show the diameter of the circle by this method. This we have learned when we had a lecture on dimension. So in order to represent this diameter, we can draw a dimension line at an angle of around 45 millimeters passing through the center. Then we will add arrowheads outside the circle pointing towards the circle. Then at this end we will add a tail. So we'll call that this is a leader line. On that leader line we will mention its value 516. And remember, whenever you are dimensioning a particular circle, we have to talk about its diameter only, not radius. And in order to represent diameter in front of dimension, we will label symbol 5. So it means dia 16. Now after that we will show this radius also, that we can show with the help of a leader line. So we will draw a leader over here, inclined line at an angle of almost 45 degrees. Then arrowhead pointing towards that radius. Then at the other end of inclined line we will draw a tail, horizontal tail. Above that we will write R20. And remember, for radius we always mention R. And for arcs we always mention radius only. So after that we will place other length dimensions, that is 24 millimeters, this one. And after that we have to place the remaining width dimensions. So we are done with our drawing. I hope the answer of this particular question is clear to you. Thank you.